Hey everyone, it's Dan, and today we're going to talk about energy conservation, specifically in a Physics 20 classroom. Simply put, the concept of energy conservation means that energy cannot be created nor destroyed. In the Physics 20 program of studies, this concept is found in Unit C, in which General Outcome 2 states that conservation of energy in an isolated system is a fundamental physical concept. Now what this means is that for a Physics 20 student, they need to know what the principle of energy conservation is. With an understanding of energy conservation, a student can set up all sorts of inequalities and equations to solve a large array of problems. Without it, these problems become impossible. In summary, Physics 20 students need to understand that energy conservation means energy cannot be created, nor can it be destroyed. There are many ways in which a teacher can develop an understanding of a student's prior knowledge. However, in this video, I'm just going to focus on 3. First off, a simple way to get an idea of a student's knowledge level is to give a quick quiz. It does not have to, and probably should not be for marks, but it can be a great way to gauge the knowledge level of individuals within your class. The next method was discussed by Julie Gooding and Bill Metz in their article, From Misconceptions to Conceptual Change. The method they suggest is to evaluate the class as you go. By carefully listening to students' responses in class, you can gauge the knowledge level through informal assessment. The third way to determine knowledge level within the classroom is to use the program of studies. Within the unit guide, there is a list of relevant materials from previous years and classes. From this, teachers can go back and figure out what students have, or at least should have, learned in previous years. The most common misconception that students may have about this concept is that energy is not actually conserved. In Students' Misconceptions about the Energy Conservation Principle, an article found in the International Journal of Environmental and Science Education, some very reasonable misconceptions are pointed out. Some of these misconceptions include the ideas that energy can be created by fire or destroyed by decay, or created and destroyed in all sorts of ways. Another interesting misconception is that students may believe conservation is equivalent to saving, so they believe energy conservation is about saving energy. For the most part, these misconceptions all come from a misinterpretation of the word conservation. Once an understanding of conservation has been made, the concept becomes very clear. There are many strategies that a teacher could use, but once again, I'm going to focus on just 3. The first thing a teacher can do is attempt to anticipate the misconceptions. This goes hand in hand with the techniques for identifying misconceptions from the Gooding and Metz article. If a teacher is able to predict when a misconception may be coming, they can give special attention to make sure the confusion is cleared. Next, another effective method is to allow students to discuss and think through the misconception. If a student is able to figure out the error through their own thinking, they are more likely to remember the concept properly. Lastly, it is important to revisit the misconception often. It can be a very difficult process to unlearn something. A teacher can aid in this process by frequently going over the misconception and the corrected concept.